afternoon, everyone. We are going to look at probability distributions. Normal distribution is part of the probability distributions we're going to look at. And for us to go in depth discussing normal distribution, we need to understand the properties underlying the normal distribution probability. The normal distribution probability looks like this. It has the following characteristics. Number one, it is asymmetrical about the mean. Means the left mirrors the right side. The second property is that the probability under the graph should always be 1. And the distribution is bell-shaped. The tails don't touch the base. So as you can see, it is bell-shaped. It's asymmetrical, meaning the left mirrors the right. The area under the graph is actually the probability, which must add up to 1. And that means that if the left quadrant is 50%, the right quadrant is also 50%. This is what makes it become a full 100%. So now, for a normal distribution, let me make it known to you that you will always be told. So we have what we call the standardizing formula for Z, which is called x minus mu over standard deviation. If you're given a sample size, it's given by x minus mu standard deviation over the square root of n. Before I go in depth in explaining how to go about the normal distribution, it will be imperative for you to first of all understand how to read the tables. Now, the tables are read in two ways. Read from outside, for instance, 1.23. You go into the table here, you check under 1.2 and 0.03 where they meet. 1.2, 0.03, where do they meet? 0.8907. 0.8907. So that is a reading for 1.23. That is a probability reading for 1.23. It is 0.8907. So this means the distance from here, to here, 1.23, this is about 89%. All right. So if I were to ask, do you give me the Z for the probability 0.8907, you simply tell me it's 1.23. Just add this Z plus the top part there, get 1.23. If that is clear, I would ask you to give me the reading for 1.96 and the reading for 2.05. 1.96 for the ladies, 2.05 for the gents. I'll broadcast 1.96 and 2.05. 1.96 for the ladies and 2.05.
For 1.96, is that 0.9750?
Yes, 0.9750. Good. And 2.05, what's the reading for 2.05? Gents. You go under 2.0 and 0.05 where they meet. What are we having?
0.9798.
So you go to 2.0 and 0.05 where they meet. We get to 0.9 798. Yeah, 9798. Now, if I were to ask you to give me the Z for the probabilities for 0.9798, you tell me it is 2.05. If I also asked you to give me the Z for 0.9800, this is still the closest. Not this one is further by 3, this one is less by 2. So you pick the closest possible. So let's do that simple exercise again. What is the reading for 0.9803 and 0.8413? The ladies give me the top part, the gents give me the bottom part. Let's go in that order. Zero point 9803 the ladies and 0.8417. What is the reading? So if you don't find the exact, you get the closest possible.
2.06.
So 0.9803. So we have an exact figure, 2.06 here.
Yes.
Correct. How about 0.8417? What is the Z for this one here? You check from inside. Which number is equal to or close to 0.8417? Inside the table, they're cumulative, they're not just scattered, so you can easily ladies.
1.00.
Yes, 1.00. 0.8413, but the closest to this one is the same one. So we're done with the first part of reading the tables. Anyone behind? All right. Now, the properties of Z-score have been discussed. Now I want to look at the 4 rules that we need to know. Number 1, you need to learn how to illustrate, shade, standardize, and apply. So if you see this shading, whenever the shading is to the right or greater, it means you shade to the right. The right can be shaded in 2 ways. Part A shows you a small quadrant, which starts from the left side to the from the right side to the right. So this shading is smaller than 1, because we know that from this end up to the end we're getting 100%. So if I were to ask you from here up to here, if it was 80%, what would be the area of the shaded region? What would be the area of the shaded region? If from here up to here, it's 80%, the shaded region would definitely be 20%. How do you get 20%? You subtract 1 minus 0.8. All right. Then if the shading is to the right, that is going from the Z, which is negative, to this side, we are simply going to read the answer directly from the table. I will teach you how to use both tables, but for now I want to dominate on one table, which is enough for you to understand. So what does this shading tell you? The shading tells you that it's a small area, it's a big area. So the answer must be more than 50. Similarly, part C tells you 2 things. The figure C tells you that we are shading to the left, so this is less than, and the shading is smaller than 50, so we subtract our answer from 1. But D is going to the left, so it's also less than, but we are going to read direct because the reading is a bigger shading. Now, we're going to look at an example. Suppose our mu is 10 and our standard deviation is 3. Find the values of the probabilities x is greater than 16, x is greater than 5, less than 15, less than 8. So I'm going to do the first two together with you so that we can move in that order. So our mean is always found in the middle, asymmetrical. So our mu is 10, 16. So we identify 16 based on this 10. 16 cannot be on the left side if we're following a number line. 16 is on the right side of 10. So we put our 16 and a divider there. What determines where to shade, whether to the left or to the right, is a sign that we have. The greater is always to the right. We cannot read the 16 in the table. We need to standardize it. Standardize it is to reduce it to a figure that is readable by the table, statistical table. So how do we standardize? X minus mu over standard deviation. 16 minus 10 divided by 3, which is 6 over 3, which is 2. So this 16 is equivalent to 2. This 10 is obviously always significantly equal to 0. So these two, we're talking about the area from here up to here is the reading we're going to get, but we're interested in the reading on the shaded region. So from the application, we're able to tell that this is a small region and we need to subtract it from what? From 1. So when we go to these two in the reading of the table, so 2.0, we go under 2.0, the reading is what? 0.9772. 0.9772. The reading from here, 0.9772. What does this tell you? This region is greater. So we're going to get this shaded region by subtracting 1 minus this region here, because from here to here is 97%. The remainder is what we're interested in. So can we subtract 1 minus 0.772? What we get? 1 minus 0.772. What are we getting?
0.0228.
0.0228. Great. Okay, so we've done the 4 steps. Number 1, illustrate. Number 2, shade. Number 3, standardize. Number 4, read and apply. Our application is we're going to subtract because this shaded region is smaller than 50. Let's do this together. X is greater than 5. Step 1, illustrate. So the 10 is here. We identify the 5. The 5 is on the left side of 10. We put our divider here. Shading is based on the sign. You can't shade on the left because this is greater. So we're going to shade to the right. So we're shading this whole region here. And already this region tells you that the shading is greater than what? Greater than 50. So in this case, we have greater shading here. So step 2, we standardize x minus mu over standard deviation. 5 minus 10 over 3, we're going to get so we have negative 1.6666. So you always round off to the nearest 2 decimal place. So we're going to have negative 1.67. So we're going to read negative 1.67 from the table. Now this table has positive numbers only. So it means all the readings exceed the middle line. 1.67 to 1.67. So 67 somewhere here. So 0.9525. 0.9525. It definitely can't be this small region from here to here. It's obviously from here to here because all readings that are crossing the middle line are the positive ones. So the whole reading here will be gotten directly because this reading is greater than 50. So we're going to get 0.9525. We don't subtract from 1 because from here to here is evidently acceptable to be 95% and 5.25%. Now, let's try this one, 15. I want the ladies to start. X is less than 15. Step 1, what do we do? Step 1, what do we do? Illustrate. So 10 is here. Where's the 15 going to be? On the left or the right of 10? This 15, where are we going to put
On the
it?
right.
On the right.
No, on the left.
On the right of 10 because it's greater. 15 is greater than 10, so it's obviously here. Numbers that are less than 10 and 9 downwards. Now, where do we shade? On the left of 15 or on the right of 15? Because the sign says less. So which side are we shading? Left side.
Left side. Because
Don't shade up to this point. Shade until you can shade no more. So you shade the color of this region. This region can evidently tell you that this region is greater than what? Greater than 50. So whatever we get the reading directly. So to standardize this, it's x minus mean over standard deviation. So our x is what? 15. Our standard
15.
mu is what? 10. Standard deviation is what? 3.
3.
So our z will be 1.6666. The nearest 1.67. So the answer we're going to get, we're not subtracting, we're reading it directly, which is 0.9525. That is the answer. Now we go to the gents. Less than 8. Step 1, what do we do? Less than 8. Gents, step 1, what do we do? We illustrate. Our 10 is here. Yes. Derek, where do we put the 8? On the left, on the right of 10?
Illustrate.
Yes, we illustrate. So where do we put the 8?
On the left.
On the left of 10, correct. We're going to put it here. And we put our divider here. Where are we going to shade, Derek? Laser. Where are we shading?
We are shading on the tail end, on the left, after 8. Am I right?
Yes, because of the sign. Which
Yes,
says what?
there.
Yes.
Yes.
Okay. So we shade on the left. Then what do we do? We standardize. How do we standardize this 8? How do we standardize? How do we standardize the 8?
maybe we say Z equals X minus mu divided by sigma.
Yes, so 8 minus 10 divided by our sigma, which is 3. What are we getting? Negative what? That is 0.67. Okay. Why is negative? Why is negative? Because all values on the left side of 0 are always negative. Okay. So now we identify the 0.6, negative 0.67. Okay. Give me the reading for 0.67. What is the reading for 0.67? Ignore the negative. What is the reading for 0.67? Anyone, quickly?
$0.44.
And 0.07. What is the reading? 0.7486. 0.7486. Okay. So 0.7486. Is it? 0.7486. So obviously this is the reading from here up to here. So how do we get the remainder here? Do we read directly? Do we get this reading or we subtract from 1? Okay. So here we can write Z is less than 0.67. You can use any of these notations in terms of Z or in terms of X. So we're going to subtract because the shading is small. So 0.7486. What are we getting? I need you to participate. I need you to participate.
We are getting 0.2514. 0.2514.
5.14.
Yes.
All these lessons will be uploaded online on YouTube. You can access them. I'll be sending you the links. I need you to be as participative as possible. And please don't embarrass me online. Like, I'm not teaching you like babies. Be as participative as you can. I need you to understand every bit of what I'm explaining. This is very important. All right. I want to go to intervals, but I cannot go to intervals until you understand this. Ladies, X is less than 17. How do we illustrate this? Step 1, illustrate. Our mean is here. Our sum deviation is here.
Yes.
Okay. Yes, Tandy. Let's identify the 17. Where's the 17 going to be?
On the right hand side, because it's greater than 10.
on the right hand side was greater than 10, and we put our divider here. Where are we going to shed?
From 17 going to
Left or right?
right.
Right. Anyone else? Is she right?
Left.
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 Anyone else? Left. Is he right?
We are going on the left since it's less, x is less than 17.
Excellent. We're
Going on
to
the
shed
left.
on the left. What determines where to shed is the sign. All right. So then what do we do? We standardize. 17 minus what? 10 divided by our standard deviation of 3. What do we get? 7/3, which is what?
2.33.
133. Good. Already, this reading is greater than 50. So we're going to read directly, isn't it? We're not going to subtract because this whole region is big. So give me the reading for 2.33 quickly. What is the reading for 2.33?
Zero 0.9901.
Good. 0.9901. So from here to here, 2.33 is 0.9901. So you can write x is less than 17. Or if you want, you can write the probability of z less than, in terms of z, 2.33. Final answer will be what? 0.9901. Now, let's go to the test, just on these principles we've just discussed, so that we understand what was supposed to be done. All right. So now we're given this exam question. We are told that suppose the selling price. Let me put it on a working sheet. It doesn't become any harder than this. I want to make this course harder to fail than to pass, unless you just want to fail. Suppose the selling price of various houses in Livingston follow a normal distribution with a mean of 276 and standard deviation 32. Again, the probability that the next house in Livingston will sell for more than 206. What have we been given? Our mu is what? Our mu is what? 276, right? And our standard deviation is what? 32. I'm scrapping out the zeros to make it easy for you. Part 1. What is the probability that the next house in Livingston will sell for more than 206? So what are they asking for? Part 1. X is what?
Is greater.
X is, what's a synonym for more than? Is it less than or greater than? Come on, don't embarrass me. I was explaining this. Tandiwe, more than is synonymous to what? Greater than.
To greater than.
This is how easy it is. So let's follow the 3 steps. Number 1, what are we going to do? illustrate, right? So what is on the middle here? The mean. What is our mean?
Collins,
Uh-huh.
is the mean okay? I think you put 206 in the brackets there.
The mean is 276,
CT.
but here we're being asked the value of the probability 206. What is the probability that it will
Oh,
be greater?
okay. Oh, all right. Okay.
So this is the value we're grading it against. So 206, where are we going to put the 206? On the left of 276 or on the right of 276?
On the left, because it's less than.
Good, on the left. So we put our divider here. You put 206 here. Okay. Where are we shading? Where are we going to shade? On the left or on the right of 206?
On the
Right.
right, because x is greater.
Good. On the right, because it says greater than 206. So we're shading on this right. So step 1, illustrate. Step 2, shade. Step 3. What is the third step? Standardize.
Standardize.
So I want to standardize this 206. Help me standardize this 206. So we're going to get what? 206 minus 276 divided by what?
We're going to get 32,
32. Good. What are we getting?
negative 2.19.
2.19. Great. So this shading, is it more than 50 or less than 50? The shading is more than 50 because it's crossing the middle line. So whatever we're going to read, make sure that it should be more than 50%. So let's go and read in our tables the reading for 2.19. Okay, what's the reading for 2.19?
Online. 0.9857.
Good, 0.9857. We go here, 0. Meaning we're not going to subtract. We're going to
Collins, this z is equal to 2.19. It's supposed to be z is equal to negative.
yes. So negative this side, yeah. 0.19. So x is greater than negative 2.19. So what did we get as our reading? 0.9857.
857.
Great. All right. Then the other one, calculate the probability that the next house will sell for less than 220. Who wants to try? Less than 220.
Sorry, when we get to this stage, do we round off to 2 or do we just leave it with the 4?
Leave it to 4 decimal places.
Okay.
4 decimal places.
Doesn't the z-score change when it's negative?
No, the negative just tells you that you're on the negative side of the quadrant. Otherwise, you can't get a negative probability. So this shaded region here, since it's more than 50%, you're going to read it directly. Don't subtract from 1. But I'll teach you also how to use the other table. The other table will give you a small figure, which is subtract from 1. So if the reading you're getting, you're using the negative table, you need to subtract that one answer from 1. Make sure that the final answer is more than what? More than 50%. So this is 98%, which is making sense. So what is the probability that it will sell for less than 220? So we illustrate. Okay, then it's 276. Then 220 somewhere here. Then we're going to subtract. We're going to shed the left side because saying less. So this